Good morning, and thank you for joining us today for the Boiler Room Detective webinar. I'm Erin Holohan Haskell of heatinghelp.com, and it's my pleasure to introduce our guest speaker, Ray Wohlfarth. Ray has spent over 4 decades selling, servicing, and installing boilers and commercial HVAC systems. He is also a columnist for several industry magazines, has written 8 books, and teaches courses. Today, Ray is going to help us sharpen our troubleshooting skills. If you have questions during the webinar, please type them into the questions section of your control panel, and Ray will answer them at the end. Thanks for sharing your knowledge with us today, Ray.
Oh, good morning. Thank you. I was so looking forward to this. We have all kinds of neat pictures that I wanted to show, and we're going to walk through a boiler room and uncover some clues about how the boiler is operating and what we can do. One of the things I do, the first thing I do is to walk in and make sure the boiler room door is open, make sure it's safe, and then right before I go to test the boilers, I like to close the doors to simulate the actual conditions. We've had boilers that worked really well with the doors open. Once you close the doors, it was a negative condition in the boiler room. The other thing I like to do is make sure that I'm safe. In the old days, the coal miners used to use a canary in the coal mines, and if the canary stopped singing, you took off and ran because it was carbon monoxide. Well, customers today wouldn't allow you to bring in a canary into their building. So I use the next best thing. I use a personal carbon monoxide detector. And I keep it clipped to my belt just to make sure it's safe when I walk inside a boiler room. Why is carbon monoxide so dangerous? Well, what happens, this is from Bacharach, this screen, and it goes all the way from 35 parts per million up to 12,800 parts per million. And at 12,800 parts per million, you have death within 1 to 3 minutes. Now, I always wondered, like, how do they know that? Did they have some sort of a job fair where they said, hey, we're going to put you in a room for 3 minutes and you'll get paid all kinds of big bucks? Now, one of the things when I was doing a seminar, a technician said to me, oh, I don't want to spend all that money on a carbon monoxide detector. I went to Home Depot and I picked up one of these that plugs in. And I said, well, you can't really use that. He said, oh, yes, I do. And then what you want to do is in the red printing down below, under the UL standard, the carbon monoxide detector reaction time, if it's over 400 parts per million, is 4 to 15 minutes. Well, if you're over 12,800, you'd have been dead and they'd have been planning your funeral already. So these are not a good idea. And I guess the guy was not the only one that was doing this, because according to Kitty, which does the Nighthawk, they tell you the CO and gas alarm is designed to act as a monitor, and it's only for use in short-term testing. So I guess this guy was not the first one to do that. Now, just to show you how small a part per million is, and that's what we're measuring when we're looking at carbon monoxide. 1 part per million is 1 day in 2,700 years, 1 inch in 16 miles. And for those of us that have been stuck at home and like the vermouth, 1 drop of vermouth to 80/5 of gin. Why is it so bad? Well, what happens is your body actually prefers carbon monoxide to oxygen. And what happens is the carbon monoxide displaces the oxygen in your blood and it forms carboxyhemoglobin. And it essentially starves your organs for oxygen. One of the things that's particularly troubling with carbon monoxide or carboxyhemoglobin is it has a 5-hour half-life. So if you're in a boiler room and you're exposed to 500 parts per million, and we pull you out and we get you out in the sunshine, and we're social distancing away from you, but it's going to take 5 hours for that level in your blood to drop down to half that amount, or 250. and it's going to take another 5 hours for it to drop down to half of that again. So it does take a long time. In severe instances, they'll put you in a hyperbaric chamber in a hospital to try to force more of that out. What do you see? Everybody's been looking for Kim Jong-un. Well, I found him, and he's looking inside our boiler rooms with us. This was one, plan your escape. When we went to this job site, the director of maintenance for the facility said, the boiler's over there, over that pile of garbage, and you need to go over there and fix it. I said, well, I'm not going to go over there and fix it. You need to get this junk out of your boiler room. He said, well, the last guy fixed it for me. And I looked on that radiator here, and I'm thinking, oh my gosh, he put a cross on here in case he didn't make it back or something. But you got to be able to stand your ground. And in some jobs, you're just better off to walk away from, because it would have been really problematic to get back to that boiler room. One of the troubling things with steam is it displaces oxygen, so you don't breathe as well, and there's zero visibility if your boiler room is filled with it. So you're walking through like a blind ninja trying to find your way. And then just think about the last boiler room or basement you were in. There's all kinds of things that are strategically placed at the height right below your knee, so you hit it with your leg, or at your head level. So make sure you plan your escape and try to visualize where you can go to get out of the place. Boiler room dangers. This is my church, and it's frustrating as anything, because I say, whatever you do, don't put anything dangerous inside the boiler room. Well, obviously they don't listen to me. So, and Weil McLean has a particularly interesting list of things that they talk about, and I'm going to go over that in a second. Like what's stored in a boiler room? This was a healthcare facility, and it had all kinds of chemicals in there, and it was off-gassing, and you could see they were going through all kinds of igniters on the lock bar because they didn't react well with the stuff in the tanks. So make sure your boiler room's able to breathe, and make sure that that it's safe inside there and there's not chemicals that are going to react. Weil McLean put this together, and I thought it was a pretty interesting thing. And I would challenge you to think about your last boiler room that you visited. Look inside, look on this list. I would bet that there's at least one or two of these items which were in your last boiler room. For example, sodium chloride for the water softener. Every steam system and a lot of the hydronics use water softeners. Calcium chloride for thawing. So look around and see if there's things that do not react well with your flame. One of the things that I like to look at is look at the burner. You can see the flame roll out here. What's that telling me? It's telling me that something is pulling the flue gases out. And it's either going to be plugged flue passages, maybe it's sooted or rust is covering it. This is a dangerous situation because carbon monoxide is like that angry old guy that's out and yells at all the kids, don't come in my yard. Anytime it changes, carbon monoxide likes to spike and elevate. So when you're pulling the flue gases out backwards like it is, you're going to have really high CO. And this is things that have to be looked at, and you need to document this when you're on a job site. Because what's going to happen is they're going to say, oh, Ray was the last guy here, and he looked at that and didn't think anything about it. Look under the draft diverter. That's one of the first things I do. If you see a lot of rust like the one on the right or even the one on the left, it's telling me that either the flue gases are being pulled out or it's condensing or something's wrong. And you need to have that thing looked at to figure out what it is. It could be an exhaust fan. it only takes 3/100ths of an inch negative to pull the flue gases from a burner, and so you want to look at the exhaust fan. On a commercial building, what you'll have is if you have an exhaust fan, you're going to have a makeup air fan, and they should be interlocked electrically to make sure that you're not going to pull that room into a negative. In residentially, you could have exhaust fans in a room, in a adjacent room, or in the house. We were at one job where they were having carbon monoxide alarms going off, and the person had all of his exhaust fans on because he had 4 kids and they were taking showers, and it pulled the room into a negative condition. How can you tell if it's negative? Well, the picture on the left is a smoker that you can use that in the old days, when we used to smoke, you were allowed to blow smoke and see which way it went. This kind of tells you which way the smoke is going to go, if it's going to be pulled out of the boiler room or basement. If I don't have one of those with me, I'll use a simple strip of toilet paper, and I'll walk to the boiler room or basement door, and I'll open it just slightly, and I'll hold the toilet paper, a strip of it down. I know it's worth a lot of money now, but this was back when you could get toilet paper. But you open up the door, and what it does, if it's a negative in the room, it'll start swaying toward that door, letting you know that there's a negative condition in the room. On one particular job we went to, they were having a negative condition, and it was because the makeup air was tripped on the freeze stat, and they still had the exhaust fan running, so it's pulling the whole room and whole building essentially into a negative, and flue gases were coming out and overcoming the people in the facility. Clean heating services. Soot is really dangerous, and this is kind of one of the reasons why I started doing safety talks. And we had a client of ours that was a really nice guy. He was a custodian. He became a maintenance person at a school district, and his boiler sooted. And what he did was he started to clean the boiler. Well, that soot gets everywhere. As anyone has ever cleaned a sooted boiler knows, it is everywhere. And there isn't a soap in the world that will help you to get rid of it. Well, he hit the boiler one time with a wire brush. It ignited the soot. He got 3rd-degree burns up his arm and 2nd-degree burns on his face. He never came back to work because he was burned so bad. If I'm cleaning a sooted boiler, a lot of times I'll get a little spray bottle from a dollar store and just spray it with water. And then I use plastic brushes to clean it so that it has less likely of a chance for it to ignite. Let's see. The boiler on the left, I was called there, and they said the day before the boiler on the left was cherry red. They said, "Can I still use this?" I said, "Absolutely not." It's funny, people look at this stuff and think it's okay. And the one on the right, they were still firing this. So you could see the discolored jacket where the arrow is. It's telling me that the flue gases are not going where they're supposed to go. So they're coming up the side of there. So you're going to have carbon monoxide, and you're going to be spilling into the boiler room. So if you see something like this, make sure that you take care of it and make sure the system's safe. I don't know about you, but this really scares me. When I walk onto a boiler room and I see the 4x4 covers gone, it makes my spidey sense start to tingle. And I'm thinking, did they jump out the safety controls? What did they do? And the ASME CSD1 even references this too, that they want these 4x4 covers put back on. This job, and it came and it was installed, and when I went on a service call, the serviceman or the director of maintenance said, "Hey, be careful when this thing fires up." He said the flames roll out the sides, so don't be near the sides. And I'm like, what? So I looked at this, and sure enough, when this thing came on, it ignited and the flames rolled out the side of the boiler and up the side of it. And so I started looking at the gas stream. This has been in about 30 years. And if you see the gas stream where the red arrow is, this gas valve was upstream of the gas pressure regulator. So when this valve was shut off, the gas pressure regulator is set for a certain pressure, and it's like, wow, I need this pressure. So it opened wide open. So as soon as the main gas valves opened, this thing was at full open, and then it took a little bit of time for it to come back. But this is something that you see on jobs. Like, it's been 30 years, and I told him, the director of maintenance, what we want to do is look at switching this over from putting the gas pressure regulator upstream of any electric gas valve. And he said, nah, don't worry about it. It's been like that for a long time. So on something like this, you want to log what's going on so you're not blamed for it. Can we use Teflon tape on gas lines? Well, yeah, this is America. You can do pretty much whatever you want. But we're starting to see more and more manufacturers are saying, do not use Teflon tape and do not use Teflon paste. And this is a excerpt from a Webster engineering manual for one of their burners. Warranties are nullified and liability rests solely with the installer when evidence of Teflon is found. That's pretty clear that they don't want Teflon tape or pipe dope, and you don't want to be the person that puts it on there and has something happen. One of the things I get asked quite a bit is, what about the yellow tape? You know, it's made specifically for gas. And I said, you really need to check your maintenance manual or installation manual, because some of these companies are really adamant about not using not using Teflon on gas trains. When I'm looking at a commercial boiler with a power burner, I check the tightness and connections on the wiring terminal every service call. This burner is going to be operating at 1700 to 3400 RPM, and what will happen is these screws that hold the wiring to the wiring terminal will loosen up, and you can see where the arrow is here. It just burned us right away. So I like to do those. And one of the other things you'll do is, if I'm having a problem on a job and it's an intermittent failure, the first thing I do is check the wiring terminal, because a loose wire can drive you crazy. You think that you have it figured out, and then all of a sudden it fails. This one was sent to me, and when I do my seminars, I always ask the attendees if they can send me some information, pictures that they see on the job site. And a friend of mine from Johnson Controls sent this to me, and he said, they fixed that breaker tripping, and so it's just the crazy stuff that you see out there. Draft controls on a Category 1 boiler are used if the stack is over 30 feet high. One of the things we see all the time is they forget to take these red stops off. The red stops are only to be used if you're firing with oil. Now, there's some controversy regarding this, that the idea is that if the flue gets plugged upstream or downstream closer to the chimney, that this can open up and allow the flue gases to roll into the boiler room, which is a scary, scary thought. So I like to use the spill switches that you can get from the manufacturer. And I think it's part of the code in New York. It's not the code everywhere, but it's a great idea. And it's a way you can upsell for the customer and make sure they're safer. What if you don't have a barometric damper? This was a friend of mine. We went to the job site and his barometric was missing. So he put in this garbage can, he drilled holes in the bottom of his garbage can. That was his barometric tamper until the new one came in. A gas leak detector is a great investment. It'll pay for itself. If you go into a boiler room or into a boiler room, and as part of your service, you use your gas leak detector to test the gas train, you can end up making it safer because a lot of times you're going to find a gas leak in there. And you can talk with the owner about making it safer for them. And you can also take this into an elevator and start that ticking and get everybody scared inside here. It's kind of fun. Water leak. If one of the leading boiler killers in this industry is leaking pipes. So on every job, I like to see a water meter. This is an old one. I like to see a water meter on the makeup line. That way you can tell if there's a boiler, if you're starting to lose a lot of water, you can trend. If your leakages are getting higher, it's a great safety item that you can sell as part of your preventive maintenance. This one here, we got to the job site and the boiler was sooted, and he said, my guy was just out here a couple weeks ago. What's wrong with this thing? Well, you can see the custodian or the maintenance person put the hole above the draft diverter here. So the boiler was sooted down below, but he was getting great readings up here. So if you're going to do a boiler with a draft diverter, you want to be able to check your combustion gases down here before the draft diverter. Emergency door switch. This is part of the CSD1, and these are a great idea. I can't stress this enough, because if something happens inside that boiler room, these door switches are supposed to be put at every exit from a boiler room. If your state or local municipality follows CSD1, and they will save lives and they will save money. This was a school district, and they got a call in the middle of the night, and their smoke alarm in the boiler room was going on. And when the fire department got there, they opened the door to the boiler room, and they said they were greeted with white, wet smoke, which is steam. So they said, well, we need to find the source of this white, wet smoke. So they went down with their thermal scanner, and they said, there it is. That's the source right there. And they took a picture of the boiler. And then the next thing they did shocked me. They sprayed the boiler with cold water while it was firing. You can see this boiler, it cracked every section on the boiler. It did $45,000 worth of damage. And they are so lucky that this thing did not happen when the kids were in school. This was happened during the night. Or they were lucky that this thing didn't blow up and land in the next county. Anytime you hit a hot boiler with cold water, you're going to shock it and destroy it. So if this building had simply had a door switch at the door, they could have hit the door switch, let the thing calm down, and then they could have just gone in and investigated and seen what the problem was. Can the boiler breathe? We see so many boiler rooms where people put wood over it, or there's grass clippings on the outside, and the boilers need to have a way of bringing air in. They think that the boiler room is too cold, so they'll put boards over it. The International Fuel Code, they give you a couple different options. If you're going to use openings in there, they want two openings, one within 12 inches of the ceiling and one within 12 inches of the floor. And they also have a one opening option, which is 12 inches from the ceiling. One of the things that we see is the combustion air louvers on a lot of the commercial jobs. And it says the motorized louver shall be interlocked with the appliance, and it's under the International Fuel Gas Code. So we see a lot of the people using the Belimo type motors, which has the switches on the side that you can set, because what it has to happen is this has to be wide open before the boilers even start. And some of the older codes had it where you had to have an end switch on the driven member, this rod here. They've kind of changed that since then, but you still need to verify that this thing is open before the boiler fires. What about if you have a residential boiler, and a lot of times people want to try to gather some of the space in there and make it a man cave or whatever it's going to be? Well, when you put walls around a boiler, the boiler can't breathe. So what the International the International Fuel Gas Code says, the indoor air requires 50 cubic feet of volume for each 1,000 BTU input. So if this is a 150,000 BTU boiler, we would need a boiler room 25 by 25 by 12 feet. Well, you kind of lost the whole idea of your man cave. It becomes a boiler cave then. So one of the things that we have used, which I like, are these Fields combustion air in a can. And you put it on the boiler room floor and run duct from the top of here to the outside, and you wire it in series with the boiler. So when the boiler fires, you bring in the combustion air. It's a whole lot less expensive than trying to bring in air from the outside a duct or something like that. Now we see a lot more of the condensing boilers and the condensing furnaces, which use the PVC for combustion air. And one of the things that a lot of technicians forget about is how the density changes with air. The colder it gets, the more dense it is. Well, what that density is there's more oxygen. So let's say we started a boiler and we set it up on an 80-degree day and the barometric pressure is 29, and we set it for 15% excess air. Well, as it gets colder throughout the year, we actually have more air, more oxygen in our combustion air, and it goes from maybe down to 30% excess air, which looks like it's going to be about a 1 or 2% difference. It's not bad, but the thing that we really want to be careful of is when I was taught in the industry, we were taught the best time to set up a boiler is when it's the coldest temperatures of the year, because the boiler has to run for 15 minutes for the flame to stabilize before you do any adjustments. And so if we do it on a 0-degree day and we set it up for 15% excess air, well, as it gets warmer, you could see it goes into the red here where we don't have enough oxygen in the air. So we could actually be starving that and sooting that boiler. So when you're setting it up, if I have a boiler with that's using combustion air directly vented, I like to have it tested twice a year just to make sure we're not getting into that red zone that you see down here. This job, it was a college we went to, and they replaced a water heater with a condensing water heater. And they didn't know what to do with the vent, so they put it in the PVC vent into the old vent. And when I got here, there was flue gases filling this whole space, and the combustion air was blowing it all over the place. And I shut it down. I took a picture of this. I wish I had a picture of the vapors coming up. But they had put this in themselves, and this had been in for about 5 years, and no one called them on it. And it's really, really dangerous. The carbon monoxide levels in this boiler room were very high. My friends at Backrack sent me this picture. How'd you like this? The guy put 1390s on the Flue, and it makes me laugh. And then he was so proud of this job that the picture's not that great, but he put hangers up here because he thought, this is my work of beauty here. I want to make sure this thing looks great for everybody. Well, how about this one? There's a wall right here, and they have the boiler outlet here. This is the combustion air right here. This is the air for the space for ventilation air. And so this is a lawsuit waiting to happen. That combustion air or the combustion gas are going to come out and get pulled into here or even ruin his brand new VRF system. So these are just some things you want to look for when you're out there. On this particular job, it was in daycare in Minneapolis, and a friend of mine sent me this. All this carnage on the left was right behind his wall over here where all these kids were sleeping. Could you imagine that? And it just destroyed this whole thing. And it's because the boilers weren't being maintained. Harold Sullivan, who was a director of maintenance at Whispering Pines Nursing Home, had a boiler that would not start. And Harold kept pushing the reset button on the boiler. Well, eventually the boiler filled with gas, and after the fourth time of resetting it, he pushed a button, and it hurled poor Harold across the boiler room floor about 30 feet into a wall, and Harold spent the next 10 years of his life in his wheelchair. And what I tell people when you're going out onto a job site and where you have a boiler, push the reset button once. If it fails again, you need to find a cause. You just can't keep pushing the reset button because you don't want to end up like Harold here. Now, I hear people saying, oh, boilers are dangerous, but I have this theory, well, there's about 10 people die worldwide from boilers. Well, if you look in Africa, 500 people die a year from hippos. That's 10 times more people die from hippos than boilers. And 150 people die from falling coconuts every year. You don't hear everybody thinking that coconuts are dangerous. And my favorite one is 13 people die each year from shaking a vending machine. And I think that, when you get up to the pearly gates, there's got to be a special couch they put you on when you're up there and they say, he died from shaking a vending machine. We're not going to let him next to a lot of other people, but if boilers are maintained, they're very, very safe. 90% of all accidents can be avoided by just simply doing maintenance. And the industry used to classify what was the cause of boilers. And most of the time it was from poor maintenance or improper maintenance. Low water cutoff was the next, limit controls, burner failure. So if your boiler is maintained and it's looked at on a regular basis, you are not going to have issues and problems like you're more likely to get killed from the coconuts falling down and hitting you on the head. This is a great tool for your technicians and your company. If your state or municipality follows CSD1, this is a great idea because ASME said, look, you have to do boiler service. And what the code says is a qualified individual shall be capable of determining the equipment is in an as designed operating condition. I love this picture here because you sit there and you think, well, who has the worst job, this guy or this guy here? This guy is just a supervisor. You can tell he's not going to do anything. The ASME CSD1 further says the owner shall develop a formal system of periodic maintenance and testing, and it shall be recorded in a boiler log or service. We are seeing some municipalities are asking to see the boiler service reports or the testing was done. And then finally, any defects found shall be corrected immediately. I found this particular flame safeguard on the job, and the guy said, oh, it's been like that for 5 years. Well, if you follow CSD1, we can tell them that this thing has to be changed. When we look at relief valves, look at these two here. The one on the right has a shutoff valve in it. This was a picture from an insurance company that was taken after a boiler exploded, and obviously the relief valve did not open. The one on the left is my favorite. the guy could just hear what the guy is saying. He's going, this thing will never leak again. I'm going to put a valve and a cap on here. I'll fix that, you know. So I get so excited when I see stuff like this. I'm like, what were they thinking? How about this one? The relief valve is put in backwards, but it made it easier to keep the spindle in a vertical position. One of the common things we see on jobs is where they will put a bushing or reducer on the outlet of the relief valve. And what happens is you've essentially reduced the relieving capacity of that relief valve. And we had one job where they had a 2-inch relief valve on it, and then a guy bushed it down to 3/4 inch. And I asked him, I said, why do you have a 3/4 inch on there? He said, well, I didn't have any 2-inch, you know, and he just thought this was okay. This is not okay. So look for this and find us on the jobs. We were called to consult on a job, and this was an interesting job where the expansion tank was flooded, and the relief valve kept weeping, open and closed, open and closed. Well, the copper tubing is piped all the way down to the ground. And what happened was when the relief valve kept opening and closing, this copper kept expanding and contracting, expanding and contracting. Well, right here on the relief valve, this was a fulcrum. It finally just snapped, and all the water in the system came out and flooded that boiler room. So you want to have a little bit of space for the expansion and contraction if that ever happens. You know, I like to put in a little air vent here with a funnel or something like that that allows for the expansion and contraction. So how about this for a service call? The guy called me and said, Ray, he says, sounds like we have a hot and heat when our boiler's firing. I'm like, what? So I go out there, and here they had jumpered out. There's a copper fin boiler. He had jumpered out the flow control on here. And sure enough, I thought it sounded like an orca whale, you know, and I felt Jacques Cousteau. And so we had to clean the whole heat exchanger out. It was all scaled up. So listen when you're going into a boiler room. Do you hear hissing or do you see steam escaping? If you hear what sounds like Rice Krispies or ticking in your boiler, that's usually an indication that scale is building up and it needs to be repaired. If you hear what sounds like sandpaper rubbing, it could be the motor or the pump bearings are going bad. How do we get water to the highest radiator? And a lot of times people will say, well, we'll use a pump to get it up there. And actually it's not a pump, it's a circulator. But what happens is I like to use Baby Yoda here. That's my favorite because he can lift it all the way up to the top there. But in reality, what you need is a pressure relieving or pressure regulating valve. And 1 pound of pressure will raise water 2.3 feet. So a lot of times I use a rule of thumb of 1 pound of pressure for about 2 feet in height. And that tells you, so if your highest radiator is 50 feet, I'll make sure I have around 25 feet or 25 pounds of pressure on there. How can you tell if your expansion tank is flooded? On these ones on the left, you can look at the sight glass that are on there and see if it is. If it's the diaphragm one, it's really hard to tell. Well, what you can do is you can look at the PTA or pressure temperature altitude gauge. And I will watch the PTA or pressure temperature gauge on the pressure side of it to see if the pressure starts to build up when the boiler starts firing. What that's telling me is that our expansion tank is flooded or it's undersized or something. This is the pressure on the outside. And then this is your altitude here or the height that it's going to go. So we're at 21 pounds. We're going to be up around almost 45 feet in the air. And then this is our temperature down below. Another thing you could do is if you go onto a job site and you see the relief valve weeping, like this one where it kept going down in, he said he had to change this. His expansion tank was flooded and it needed to be drained. This job we got called, this is for a federal government, and the engineer had a great idea. He said, what we're going to do is each zone is going to have a zone pump, and we'll have a thermostat on each zone, and it will be, everybody will be comfortable because on this particular one, they only had one zone that they used throughout the week, and the other zones were used during the weekend. So what they did was when one zone was running, they weren't getting enough flow through the boiler, so it ended up destroying the boiler in 5 years. So make sure if you're going to put zoning on, you want to make sure your boiler has enough flow so it doesn't void a warranty or destroy it. This one was a real head scratcher. We got there, it was a Friday night. You know, those Friday night, it was a cold night, and they said, we have one apartment without heat. And by the time I got there, they had turned the heat up to 210 degrees in the hydronic loop. It would scald your hands just holding the pipe. So I was there and the guy's looking over my shoulder and how much longer, how much, I'm like, I don't know. And so I tested the temperature and, you know, we were getting 210 degrees out and I was getting 208 degrees back. And I was stumped. I'm thinking, what is going on? So what I did was I ended up cutting the flow down to that particular space. And I got the flow down until I had a 20-degree delta T from the return to the supply. And as soon as I did that, that apartment heated, I had no problem. And I've had issues. I wrote an article about this. The velocity was so high that I guess it wasn't giving up the heat. Now, a lot of people say that can't happen, but I'm telling you that as soon as I slowed the velocity down, this thing heated like it was supposed to. You know, when you walk into a boiler room and you see something like this, give it a decent burial because you know this thing will fail Friday at 4 o'clock. And so as part of your PM, you need to tell the customer, hey, look, you need a new pump, you know, I need a new circulator, and that should be part of it. This one, they put the electrical box underneath here, which is not allowed because if this thing were to ever leak, it would go in and short it out. We had to change the 4 screws on here and rotate it 180 degrees. Like these small pumps, the circulators that you see, it's really hard to tell if they're running. You know, you used to be able to put a screwdriver to your ear into the pump and hear it running. And these ones here, you can't really hear. And the amp draw is so low, like 0.55 amps, that it's really hard to tell. So we use these little Grundfos things. I'm sure other people make them. And you just hold this tester up against here and it spins back and forth, spins around, and it tells you if the pump is running. These are a great idea if you go onto a job site and there's a lot of those little small circulators there. And it's about a $10 item. The 3-way valve, this was on a job site and they had put this control valve in there. And then what happened was they were cracking every year, cracking the last section of this cast iron boiler. And every year they would just make these nipples longer. They still had the same boiler on this end, but they just kept making it shorter because it wasn't piped right. When they used a 3-way valve, they were shocking the boiler and it was bringing back cold water and cracking the sections. When you're checking your temperatures on a system, if you use the infrared thermometer, a lot of times you can't use those on copper pipes because the reflectiveness of the copper. You know, maybe you can use cover it with tape or something. A lot of times I will use these little clamp-on meters and it will tell me what my temperature is. And I use the infrared thermometer when I'm checking steam traps or black iron pipe. And look for a 20 to 30 degree temperature rise on some of the commercial boilers, but you want to check with the manufacturers. What's the proper steam boiler pressure. You know, I hear people that'll tell me, well, one guy, it was pretty innovative. He put a reset control on his steam pressure, and the colder it got, the higher the steam pressure went. But essentially, what you want to do is keep it around 2 to 3 psi is what it was designed for. The Empire State Building in New York City, at 102 stories high, they won a LEED Gold award. Sorry about that. And they run on steam at 2 to 3 psi. This job we were looking at, it was operating at 8 psi steam pressure. So the steam temperature was about 234 degrees, and steam traps will discharge anywhere from 10 to 20 degrees lower. So they had condensate at 214 to 224 degrees. Well, at atmospheric pressure, it's going to flash the steam and boil. So if you're running at 8 psi, you're going to have 350% higher flash steam than you are at 2 psi. So all that is going to be wasted, and you're going to destroy the boiler relatively quickly. This job, it was a university we were called to. It's a low pressure steam boiler, and usually you'll see a steam plume like this coming from a deaerator, but they had a low pressure steam boiler. When I got there, I saw this plume of steam coming out, and so I talked with the director of maintenance, and he said, my boiler only lasted about 10 years. He said, it's a piece of junk. And I looked at this and I'm thinking, wow, unless he gets his system repaired, mine's not going to last any longer than this. So I explained to him that how the system is not supposed to have the steam coming out the plume like it is. It's supposed to have just a little wisp on the low pressure steam boiler. If I'm doing service on a boiler and they have, I like using the compound gauge, so it helps to tell me what the, if it's going into a negative, if it's in a positive, because a lot of times, if you have just a standard pressure control, you'll end up having a problem with it because it won't tell you if the system's going down into a negative condition. Now, one of the things that, since I don't have a life and I read this stuff, and one of the things that a lot of people don't understand, and we see this on brewers all the time, is take, for instance, the Combraco. It says that the minimum pressure required is 4 psi, and that means the margin. They don't want you running on a 15 psi relief valve. They don't want you running it above 11 psi, and they want you to test it at or near the maximum operating temperature or pressure. And if you have to replace it, in capital letters, it says, do not use a pipe wrench. Well, I don't know if there's some new thing out there you can use, but rather than a pipe wrench, but if you have a 2-inch relief valve, you're going to need something that's going to be a little more substantial. And then they also say, use only Schedule 40 pipe, steel pipe, for the discharge. This is becoming more and more asked for on and requested on every job site, is they want the evaporation test. A lot of these insurance companies, if we were going on to a steam boiler job, we would open up that valve and that's beneath our 150 here, and we would document that that it shuts off the boiler. Well, that doesn't actually simulate an actual condition, because you could have some junk in there that is holding up the float if this thing has a float. And what will happen is it will open, the float will drop once you drop down and once you open up the valve. But under normal circumstances, if it's just steaming away, that float could stay there and run forever and the boiler could be out of water. There could be scale or mud inside here that's going to keep it open, keep it firing. So a lot of the insurance companies are asking for this. So like on a slow drain or an evaporation test, you just shut off water going to the boiler, and then you send it out into the system and make sure that this thing actually shuts off the boiler. Use brass pigtails instead of the black iron. They're going to be less chance of rust and sludge put inside them. I like using one of these when I'm checking the steam pressure controls. You can crank it up or down, and it makes it a lot easier.
Sorry, what did you say?
The last thing we're getting close to the end here is I like to use a water seal instead of the pigtail. What the water seal is these make it a lot easier to clean and access. The other thing I like to do is I like to put my pressure controls on two different tappings coming from the boiler. If this tapping gets plugged or filled, that means that I still have this one. It's really less likely to have a failure in there. And the two openings. The last thing I have is a master trap. So if you go onto a job site and you see the master trap here, you know, it's saying run like anything, get out of there. I don't know what the red tire's for. Maybe that was the last service guy was there and said, I'm leaving. But what it's telling you is the steam traps in the building are not working, and you are going to inherit this problem if you put a new steam boiler in this building. You need to go through, and steam is more holistic than a hydronic system. You have to understand that an area that's not working in one part of it can affect areas in all sorts of places. So I'm going to be looking for some questions now. Erin, I'll leave it up to you. I don't see if there's any questions in here.
Thank you, Ray. We just had a couple of questions. They're both regarding what you would recommend to bring air into the boiler room. Can you touch upon that again?
Well, what I like to do is use the two different openings. I'm old school on there, where you can have the one opening in there that feels, if it's in a residential room, we even use one of those on a commercial. They have a combustion air in a can, it's called. And it's a little fan, it has a pressure switch on it, and you connect flex duct from the outside into the boiler room, and you wire it in series with the boiler. So anytime the boiler needs air, you're going to bring in combustion air. I hope that answered the question.
Thank you. Thank you, Ray. And Kevin is asking, what should you do if you see steam?
Well, if you see steam, the first thing I would do is I would look to see if it's a leak. The second thing, if you see steam coming from the vents, then what I would do is look like on the boiler feed or the condensate tank, I would see what my steam pressure is. If it's over 2 psi and it's for space heating, I would look at lowering it down. What happens if brewers if you work on boilers for brewers, they try to operate on 12.5 to 13 psi, which is really scary. It's way up there, and you're going to have a lot of issues with it.
Okay, and what's the most likely cause of short cycling of a two-pipe steam system?
Either air in the system or a dirty flame signal or a dirty flame rod that's cycling on and off. But most likely it's air is what I found is that the system is filled with air. And like Dan always says, you know, two gases can't occupy the same space. So if I have air in there, you know, the steam will not go into there. So you have to remove the air.
And Peter is wondering, how do I find someone who's good with a steam boiler for maintenance? He says it's hard to find someone.
I would get on heatinghelp.com and talk to somebody there. There's going to be some people that will know somebody in every different location.
Thank you, Ray. And Hubert asks, I work at a commercial property in New York City. Should my boiler supply fan be interlocked with the low pressure boiler?
Yes. It's part of the code. You want to be able to make sure that the combustion air is working before the boiler comes on.
Okay, and we have a question here from Ed, and he says, can boilers with burn marks still be used after the problem is fixed?
Oh yeah, definitely. I would definitely try to clean it up or paint it or something like that, but so you know if it ever happens again. But you know, a lot of times on those ones that had the burn marks, we would disassemble the whole thing, clean it all out, and reassemble it. And then what I would like to do is try to paint that jacket so that the next time I'm out there, if I see it's discolored again, I know that there's a problem.
Okay, and Peter is wondering, how often should we drain the boiler and refill?
Never. I don't like to do that at all because every time you drain your boiler, you're bringing in oxygen, you're bringing in hardness and scale. What I like to do is you want to limit how much water your system is making up.
Okay. And Dan is wondering, so should the goal for a system be 2 to 3 psi and all equipment/design choices be targeted to that?
Yes. What we find though, a lot of times is on a commercial building with steam to water heat exchangers, you really need to find out what their pressure design is. Typically, we see designers or engineers size those for between 5 to 7 psi. So it kind of, if when we try to run at 2 psi on a commercial building like that, it's not sufficient, and they don't get enough heat from the steam to water heat exchangers.
And a question from Benjamin. He says, how do I remove/eliminate air?
Oh, air from a steam system, that's a great idea. On a commercial boiler, they will use a deaerator, which uses steam to heat the air and removes the oxygen. On a typical small commercial boiler, you'll need to talk to a water treatment company. They'll use a oxygen scavenger like a sulfite, which will trap the oxygen and take it away from there. You also want to keep your water temperature warm if you don't have any oxygen scavenger in there, because water at 70 degrees has double the amount of oxygen in there as water at 110 degrees. So you want to try to keep it warm or use an oxygen scavenger.
Okay. And Jose is asking, does low water blowdown need to be done weekly on a system that is closed loop, or can this wait a bit longer?
Typically, if it's a hydronic boiler, I usually do that. You'll have to check with the manufacturer. I like to do it, tell them to do it once a month. If it's a hydronic boiler with a float, it's what you have to do is you almost have to get in and work the linkage up and down with a small screwdriver to make sure it works. ASME CSD1 has, if you're using a probe type low water cutoff, they recommend and require a push button to test it. So when I'm blowing down, on a hydronic boiler, I will do it maybe once every month or two. On a steam boiler, McDonnell Miller recommends once a week for a low pressure steam, and they recommend daily if it's high pressure steam.
Okay, thank you, Ray. And Jim is wondering, are you in favor of using a chemical steam boiler solution instead of water on small systems?
I'm not sure what you
He's
mean.
saying Romar Water makes one, and he's sure there are others.
Oh, okay. I don't know. I've never really used the Romar, but I really like, most of my background is in commercial, and what I tell every one of my clients is they need to find someone that knows what they're doing on water treatment and can do the tests on a monthly basis or show them how to do their tests. And because what you're going to need on a steam boiler is usually 3 different things. You're going to need an oxygen scavenger. You're going to need something that's going to help with the carbonic acid that forms, and you're going to need something that's going to stop the scale. So I don't like to take that responsibility on myself. I like to let them use a water treatment company. That way they take the responsibility for it.
Okay, thank you so much, Ray. That's about all the time we have for questions this morning. Feel free to bring your questions to heatinghelp.com and we'll get some answers for you on there. Thanks again to Ray for teaching us, and thank you to all of our attendees for joining us this morning. If you like this webinar, then you'll love Ray's books and other classes, and you can learn more about them at boilerlessons.com. And please visit heatinghelp.com for updates on future webinars and more. Thank you.
Thank you, everybody. I appreciate your time on the morning.